Okay, so I'm not really doing the full big videos so much anymore now that we're all back to in-person learning. If we go back to online, I'll start doing larger videos again. Today we're going to look at Unit 5, Section 2, which is solving equations with square roots in them. No real graphing that we're going to do here. This is more just an application in algebra, so we're going to kind of look at it. Whenever we're dealing with an equation that has a square root in it and we need to solve the equation, there's a kind of a general recursive pattern that we're almost always going to do. So let's take a look at an example here. So 5 square root of x plus 7 equals 8. This is a nice, pretty straightforward equation, and we have a pretty straightforward methodology that we need to use. So the first step whenever we go to solve any of these is to isolate a root. So I'm going to add to both sides, subtract both sides, multiply or divide, whatever I need to do to get that root by itself. In this case, I could subtract 7 from each side, giving me 5 square root of x equals 1. And now here we have a choice. So we need to get rid of that square root. In order to do that, we need to square both sides. In other words, we're going to raise both sides to a power. And you have two alternatives. I'm going to show kind of both ways that work. We can fully isolate it. We can divide both sides by 5, and we can keep going right from there. Alternatively, we can square both sides now and then deal with the fractions last. So I'll show kind of what that looks like. So let's say we wanted to deal completely isolated. So we have our 5 square root of x equals 1. I divide both sides by 5, giving me square root of x equals 1/5. Finally, I would now square both sides. A square power and a square root cancel, and I'm left with x equals, that's 1 squared is 1, 5 squared is 25. We get x equals 1/25. Alternatively, if you don't like dealing with the fractions immediately, you can actually square both sides right at this step. So I can square this, and I can square this whole thing. If I square the whole thing, this power actually distributes to both. So 5 squared is 25. Square root and square cancel, and we just get 25x equals 1. And I can divide both sides by 25. So this is kind of our simplest scenario. We squared both sides, we canceled out a root, and we were kind of done with it. So let's kind of look at our procedure here. We isolate a root, we square both sides, and we simplify. This process can repeat. So repeat as necessary until all square roots are gone. Finally, once all the square roots are gone, solve for x. And that could be something as simple as this linear equation. It could be a quadratic, so we don't really know. So most of the rest of this is I'm just going to work through various examples of what this can look like. So let's take a look at another example now. So we have something like the square root of 4x plus 1, all inside the root, minus 4 equals negative 1. So here's our second example. So again, we're going to go through those steps. First step is to isolate the root. So I want this root by itself. I can add 4 to both sides. Gives me square root of 4x plus 1 equals 3. I've isolated the root. Now my next step is to square both sides. Square and a square root cancel. I'm left with 4x plus 1. 3 squared is 9. There's no more roots. I don't have to repeat the process. I can now just solve for x. This is a linear equation, so we get everything over the other side. And we solve for x, giving us x equals 2. So again, it's pretty straightforward. If we just have a single root, there's nothing all that particularly difficult about our process. We isolate the root, we square both sides to cancel the root, and then we solve whatever we have left. Where things get more complicated is if we have other variables. So as our next layer, let's look at what happens if we have other variables that are outside the root. So let's try the square root of 11x plus 3 minus 2x equals 0. All right, so just because the equation looks different to start does not change our process. In order to actually solve this, we need to isolate the root. So I'm going to add 2x to both sides of the equation, and I get the square root of 11x plus 3 equals 2x. This now I can square both sides, so it's our usual procedure. So I square, I square. Let me move the mouse out of the way. Square and square root cancel, so I'm left with 11x plus 3 equals, and remember this is saying 2x times 2x, so that's 4x squared. All right, this is not so pretty. This is not a linear. We can't just move it to one side and then solve. We're going to have to use any of our tools for solving quadratics from our last unit or from Algebra 1. So if you have a quadratic, our options are set it all equal to 0 and then solve by factoring, solve by factoring by grouping, do completing the square quadratic formula or square roots method. So I'm going to move everything over to the right side because that side will have the positive. So I subtract 11x, I subtract 3 from both sides. I get 0 equals 4x squared minus 11x minus 3. In order of easiness, factoring is always easier. If you can factor it, you should factor it. Let's see, is this factorable? 3 and 1. Yeah, I think it's factorable. So let's see, that's a 4x and an x. That's a 3 minus and a 1. Let's double check. 4x squared minus 12x plus 1x is minus 11x minus 3. If you don't like factoring, go to the quadratic formula. That'll get the job done. This I can now solve, so that gives me 4x plus 1 equals 0, or x minus 3 equals 0. So 4x equals negative 1, x equals negative 1/4, or x equals 3. Now here we have a problem. We did all this work, we got 2 nice solutions that worked out fairly clean. However, we have to be really careful. Back when we talked about absolute values, we talked about solving absolute value equations can result in equations that don't, or answers that don't work. Extraneous solutions is what we call them. And the same thing is here, only much more prevalent. Any time that you have multiple square roots, or you have a square root with the x and then another variable, you have to check for extraneous solutions. So I'm not necessarily going to show all of it out. I'm just going to kind of do a visual check. So if I plug in x equals 3 back into the original, that'd give me the square root of 36 is 6, minus 6 is 0. Okay, that works pretty well. I plug in a negative 1/4. Oh man, let's see, that's negative, well, let's see. Negative 11/4 plus 3 is 1/4. So that's 1/2. Because 3 is 12/4. Minus negative 1/4, that'd be plus 1/2. And it looks like that does not work. In this case, this is ugly enough. I'm just going to dump it into a calculator real quick and double check. Just to make sure, you know, I might be messing something up. So 11 times negative 0.25 plus 3, which is 1/4, and then square root of that is 1/2. That works. But we get 1/2 plus 1/2 is 1, which is not 0. That solution is no good. So you have to double check. It's possible for one of them to work. It's possible for both of them to work. It's possible for both of them to fail. So you must double check when you go through and do these. All right, let's look at a couple more. All right, our next example, square root of 3x plus 7 equals x minus 1. 7 should be inside the root. Okay, here, first step is isolate the root. It's already isolated, so we can square both sides. When I square both sides, this is now foiling. That's x minus 1 times x minus 1. You have to do out the whole process. On the left, the square and the square root cancel. On the right, we have to FOIL that out. Remember, that's x minus 1 times x minus 1. So that's x squared minus 2x plus 1. And we're back to a quadratic again. We have to solve a quadratic just like we did in the last unit. So I'm going to move everything over to the positive side. So minus 3x gives me x squared minus 5x, minus 7, minus 7, minus 6. Again, when you go to solve these, use whatever method is the easiest and simplest. This is factorable, I think. Let's see. So that's factors of 6 add to 5 would be a 6 and a 1. So x minus 6, x plus 1. Double check it. That's x squared plus x minus 6x is minus 5x minus 6. It's good. So we get x equals 6 or x equals -1. Now looking at these, we have to plug them back in and double check. So we plug in the 6, that's 18, that's 25. Square root of 25 is 5. Okay, 6 minus 5 is 5. All right, 6 worked. If I plug in the -1, it gives me 4. -3 plus 7 is 4. Square root of 4 is 2. -1 minus 1 is -2. 2 is not -2. That one failed. Our answer is just x equals 6. So you always have to go back and check. All right, we're just going to look at a couple more examples. One easy one, and then I'll show kind of the ugliest case that we can have. So 10 equals 12 square root of x minus 9. Doesn't look too bad. Same kind of thing. We need to isolate the root. So I'm going to add 9 to both sides. Gives me 19 is equal to 12 square root of x. Now you have options here. You can, like I said, we could divide both sides. In a case where it's going to give us an ugly fraction, I will tend to just square both sides first. So if I square both sides, it gives me 19 squared, which is 361 equals, and over here we get 144x. This is a little bit easier to deal with. I can now just divide both sides by the 144. And I get x equals 361 over 144. We only have the one answer, which makes sense because there was only one x in this term, or in the equation. We didn't have multiple parts. Last thing to do is just check, does it reduce? Nope, this does not reduce. Top guy would just be 1919. This guy would reduce down to 2s and 3s, so it's no good. And that would be our answer. All right, last one, let's look at kind of what happens if it all goes wrong, if we have something horrible. Worst case scenario, in our final example here, is if we have multiple roots going on and other things. Okay, so when we look at this, our first step for solving was to isolate a square root. And I'm almost always going to isolate the worst one. I want to get rid of the bad one first. So my goal is to get rid of this one because this is going to be harder to deal with. So I'm going to add square root of x to both sides. That leaves me a square root of 2x plus 1 equals 1 plus the square root of x. Okay, we've isolated the harder one. That way we can get rid of it sooner. I now need to square both sides. Left side is easy, it cancels out, we're just left with 2x plus 1. That's looking pretty good now. The right side is now where it gets a bit ugly. That we have to FOIL. Remember, that's 1 plus the square root of x times 1 plus the square root of x. So we have to actually go through and do our entire FOILing process on that. So if we do that, we get 1 plus root x is plus 2 root x, plus square root of x sub square root of x is just x. Okay, we did all that work and there's still a square root in it. So we repeat the process. We need to isolate the square root and square both sides. Subtract 1 gives me 2x equals 2 root x plus x. And I subtract x from each side, I get x equals 2 root x. And now I can square both sides again. Gives me x squared equals 4x. Okay, this is, again, it's still a quadratic. We need to solve it the way we solve the quadratics. So I'm going to move everything over to one side by subtracting 4x from both sides, and now solve this. This is still factorable. There's a common term of x, that's x times x minus 4. So I get x equals 0, 4, x minus 4 equals 0, so x equals 4. Again, especially in uglier cases, we have to double check. If I plug in a 0, that gives me 1 minus 0 is 1. That works. If I plug in a 4, that gives me 9 is 3. 3 minus 2 is 1. It worked. So in this case, both solutions are good. So that's kind of all we have today. It's just practicing solving roots. It's always that same basic procedure. So when we go to solve roots, you need to isolate the root first, square both sides to cancel out the root and simplify. Then do that over and over again until all the roots are gone. Finally, once all the roots are gone, then we will solve for x with whatever methodology we have to use. Most commonly, it'll result in a linear equation, or it'll result in a quadratic that we'll then have to solve.